Welcome to tonight's video on part 1 of Unit 3, and that's what we'll talk about, integral and rational exponents. So the first couple things here are definitions, talking about how when you raise it to a negative exponent, it's the reciprocal of the positive. And when you raise base to 1 over n, it's the nth root. And when you raise it to a fractional exponent, remember a to the m over n, remember it's power over root. Then there's some theorems. Remember, if you're multiplying with things of the same base with exponents, you add the exponents. If you're raising a power to a power, you multiply the exponents, and if you're dividing, you subtract. Here, if you're raising a fraction to a power, you can distribute that exponent to both parts of the fraction. Same thing if you have a product to a power, and any number to the 0 power is 1. And in order for two things of the same base with exponents to be the same, the exponents have to equal, and we'll use this to solve exponential equations. Radical theorems, remember, you can take the product of, if there's a product of a radical, then you can take the product of each term separately. When you're raising a radical to a power, you can write it as the radical of that number to the power. And then when you divide radicals, you can split it up into a quotient. And when you take a radical of a radical, then the index is the product of those radicals. Now, when do you take absolute value? Well, the square root of x squared is the absolute value of x. Square root of x to the third, that's x rad x. Think about it this way, you just divide, because it's square root, you divide the exponent by 2, and how many times it goes in evenly, that's the power of x that you take out. So 2 goes into 4 twice, so it's x squared. 2 goes into 5 twice, and you have 1 left over. 2 goes into 6 3 times, and it's going to be absolute value. 2 goes into 7 3 times. 2 goes into 8 4 times. 2 goes into 9 4 times with 1 left over. 2 goes into 10 5 times. Take the absolute value. And 2 goes into 11 5 times. Square root x. Now, when do you need absolute value? Well, you need absolute value when the root is even, the exponent in the original problem is even, but when you simplify it, it is odd. So it's even, even, odd. So like x squared, that's an even radical, even exponent, but then odd exponent when you simplify. That's when you need the absolute value. All right, so then simplifying into exponential form, there's 3 things. We're going to change all radicals to exponents, simplify the coefficients by prime factorization, and then the variables are simplified by separately combining exponents. So for example, here, this is actually 4xy to the third to the 1/2 power. So we have 2 squared, because that's 4, 2 squared xy to the third. Actually, it's going to be to the 3/2 power, because you can multiply that exponent. And then 2 squared to the 3/2 is going to be 2 to the third. Then we have x to the 3/2, y to the 3/2. All right, for the next one, now we have the sixth root of 25w to the 12th, x squared, y to the third, z to the sixth. So we can make this 5 squared, w to the 12th, x squared, y to the third, z to the sixth, to the 1/6. And then we can make that 5 to the 1/3, w squared, x to the 1/3, y to the 1/2, and z like that. Now the x to the 1/3 and the z would need to be an absolute value because it's even, odd. So we could say 5 to the 1/3, w squared, y to the 1/2, absolute value of x to the 1/3 times z. Final answer. All right, so number 3, we would now have 1 over 3 to the 4th, x to the 3rd, y to the 4th, z to the 5th, don't need that parenthesis, y to the 4th, z to the 5th, to the 3rd, and then that whole thing to the 1/4 power. So really it's to the 3/4 power. So you would get 3, so it's 1 over 3, x to the 9/4, y to the 3rd, z to the 15/4, and because it's even, odd, we would have the y to the 3rd in the absolute value. All right, the next one, number 4, we have 15 is 5 times 3 times x to the 4th. And then we have the -7th, we could make that 2y over x to the 7th, and then we could make this 1 over 5 squared. So now we have 5 to the 4th times 3 to the 4th times x to the 4th times 2 to the 7th, y to the 7th, over x to the 7th times 5 squared. Then we can combine, so 5 to the 4th over 5 squared, that's going to be 5 squared. We do have 2 to the 7th, and we have 3 to the 4th, and then we have x to the 4th over x to the 7th, so x to the 3rd on the bottom denominator, and then we have y to the 7th in the numerator. And that's our final answer. All right, so number 5, here it says we're going to take this to the -1st power, but first let's do in the inside. So we have 1 over x plus 1 over y squared to the -1st. So if we get a common denominator here, we get y squared plus x over xy squared to the negative first. So then we just take the reciprocal, and that's our final answer. So for the next one, we have 3 to the 5th, x to the 10th, y to the negative 5th. For that part. Then for the next part, 18 is 3 squared times 2 times x to the negative 3rd over y to the negative 4th to the negative 2nd power times 3 to the 4th. So we still have, here we have 3 to the 5th, sorry, pen's 3 to the 5th, x to the 10th, y to the negative 5th, and then we have 3 to the negative 4th, 2 to the negative 2nd, x to the 6th, all over y to the 8th, times 3 to the 4th. Alright, so notice when you add these, they cancel out, so you're left with 3 to the 5th, x to the 10th and x to the 6th is x to the 16th. So the x is gone. The 2 has a negative exponent, so if you move it to the denominator. And negative 5 minus 8 is negative 13, so y to the 13th would be still in the denominator as well. So there's your final answer. 3 to the 5th, x to the 16th, over 2 squared y to the 13th. All right, number 7, simplify in the parentheses first. So you get 1 over x squared minus 2x over y, and then that's to the negative 2nd. Get a common denominator, so it's y minus 2x to the 3rd over x squared y to the negative 2nd. So then to make it a positive exponent, we take the reciprocal. So it's x squared y over y minus 2x to the 3rd quantity. And we're going to square all that. So it's x to the 4th y squared over the quantity y minus 2x to the 3rd squared. Final answer. All right, number 8. Number 8 here, do it in a different color. So we have 1 plus 1 over r minus 1 over 1 plus r. So you get a common denominator. So it's 1 plus r times r over plus, sorry, and here you just need 1 plus r minus r, and it's over r times 1 plus r. So when we multiply, we get r plus r squared plus 1 plus r minus r. The r's here cancel out, so we'll get r squared plus r plus 1 over r times 1 plus r. And that's it. All right, the last couple when we deal with radicals here. So if you notice, if you multiply 3, 2, and 4, so everything that's under the last radical will be to the 24th root. But the first one, we'll do this in green. So the first one is 2 to the 3rd. So 2 to the 3rd to the 1/3, so that's just 2. X to the 2/3, y, and then this is to the 6th root, so it's 2 times 3, so it's 2 to the 1/6, times 3 to the 1/6. And then it's y to the 1/6. And then the last one's to the 24th root, so it's x to the 1/24th, y to the 1/24th. And then combining 1 and 1/6, so it's 2 to the 7/6, 3 to the 1/6. Then it's x to the 2/3 plus 1/24th, so 16/24 plus 1 is 17/24. And then y to the first, y to the 1/6, and y to the 1/24th. So the common denominator is 24. So it's 24 plus 4 is 28, plus 1 is 29 over 24. There you go. So then number 10, same concept. So this is 3 squared times 2, and it's to the 1/2 power, so it's 3 times 2 to the 1/2 x, t to the 1/2, and then it's here to the 1/6 power, so it's 3 to the 1/6 times 2 to the 1/6, y to the 1/2, t to the 2/3, because it's 4/6, and then it's 2 times 5, and it's to the, so it's 2 to the 1/24th times 5 to the 1/24th times x to the 1/8, because it's 3/24, and times t to the 1/24th. So then combining, we get 2 to the 1/24th and 2 to the 1/2. So 12 plus 1 is 13 24ths. 3, 24 plus 4 is 28. 28 24ths is the same as 7/6. And then 5 to the 1/24th. And then we have x to the first, which is 24 24ths. And then 1/8 is 3 24ths, so it's 27 24ths, which is 9/8. And then we have y. Oh, I skipped an x here. It's to the 1/6. So I gotta take that into consideration. So it's going to be 24 24ths plus 4 24ths, which is 28, plus 3 is 31 24ths. The y is 1/2, which is 12 24ths, and that's it, so it's the 1/2. And then t to the 1/2, 2/3 and 1/24th. So it's 16 plus 1 is 17, plus 12 is 29 24ths. Okay. 4 to 3/2 is 3 different ways. So 4 to the 1/2 to the 3rd. It's 4 to the 3rd to the 1/2. Or you could say 2 squared to the 3rd to the 1/2. All right, so that concludes the first part of this video. The next part, we'll talk about exponential equations.